For over a century, people have imagined a future with flying cars. We've seen them in movies, concepts from automakers, and fully functioning prototypes. Even Ford came close to purchasing the Taylor Aero car for distribution in the 40s. But the fact remains, these vehicles aren't ready for mass production. Yet, the technology available today is advanced enough to make this a reality. So, what's holding us back? For engineers, flying cars have two opposite sets of requirements. Aircrafts need to be light and narrow in order to be aerodynamic and generate lift. Cars, on the other hand, have to be wide and heavy enough to stay centered on the road and generate downforce. And while parts like side view mirrors are necessary on the ground, in the air they create unneeded drag. This reduces range and requires more fuel to fly. It can also cause instability. Meanwhile, wings and rotor blades can throw off a car's power to weight ratio. The heavier they are, the bigger a powertrain you'll need to drive. But too heavy a powertrain and the car won't fly. Vice versa, if the wings are too small, the car won't get off the ground. Developing a vehicle that meets this balance is expensive and time-consuming. That's because, unlike with cars and planes, there is no blueprint for flying cars. Slovakian company Automobil has a flying car that's taken over 30 years to make a reality. The car has required 4 different iterations. The first was simply a concept designed by co-founder Stefan Klein in the 1990s. It could theoretically fly and drive, but was bizarre looking and far too big to be used in traffic. This led to the second version, which was built in 2010 when the company was established. It had collapsible wings, could fit into a regular parking space, and had a range of 545 miles on the road and 435 miles in the air. It first flew in 2013. But even then, the company was already in development of its first official prototype, the Automobil 3.0. It featured upgrades that would be necessary on a production car. That includes a reinforced body made from carbon fiber, advanced avionics, and patented steering controls. It could transform from a car to flight mode in under 3 minutes. Despite these advancements, the 3.0 crash-landed during its 2015 test flight. Test pilot Klein lost control, and the vehicle went into a tailspin. Photos showed that the vehicle's steel framework was destroyed. If the company wanted to sell this car to the public, it would need to be much safer. So, they returned with a model almost 800 pounds heavier and a monocoque structure stronger than its predecessor. It also included an upgraded parachute system and dual-stage airbags. This newest prototype took 5 years, cost over $20 million, and required 10,000 hours of test flights for the company to be confident it was ready. After 3 decades of research and development, Automobil is awaiting government certification. The vehicle will cost at least $1.3 million and require a pilot's license. That's a pretty steep buy-in, and at that price, it's unlikely we'll see vehicles like these in mass anytime soon. To integrate flying cars into our daily routine, we have to rethink our approach to them entirely, which is exactly what companies like Uber, GM, and Hyundai have done with VTOLs. VTOLs, or vertical takeoff and landing aircraft, resemble a helicopter or drone rather than a car. Many VTOLs feature wheels but aren't made to be driven on roads. Instead, companies are investing in them to function as air taxis that fly passengers between landing pads. Although their engineering is similar to existing military aircraft, some modifications are necessary to operate in crowded urban areas, like electrification. Besides eliminating fuel emissions, electric powertrains have less complicated mechanics than jet-powered models. But that doesn't mean eVTOLs are easy to produce. They'll need to use distributed electric propulsion, meaning they'll have a redundant number of rotors and motors. Unlike a helicopter or a plane, if one rotor fails, the other will keep the aircraft flying. This is necessary when hundreds of them will be flying around crowded areas. This type of propulsion would also contribute to quieter flight. While helicopters use large rotors to generate maximum lift and prevent stalling, the small rotors used by eVTOLs would be mounted on wings and capable of tilting forward like a plane's propeller. This would allow them to spin much slower. This setup, along with the electric motors, could make eVTOLs at least 5 times quieter than helicopters. eVTOLs seem like the simplest solution, but they require an entirely new infrastructure to function. Projects like Uber and Joby Aviation's Elevate are currently designing skyports to be built throughout cities. These are elevated parking garages that feature landing pads on the top level. While fairly compact, one can cost as much as $150 million. Communication is also an unsolved but crucial element. eVTOLs need to digitally communicate with each other and nearby air towers. At the moment, all of this has to be done verbally, which is efficient and safe with only a few aircraft, not a mass fleet. Available at a limited capacity for commercial drones, digital communication allows aircraft to instantly share their flight plan data. For air taxis to be sustainable, this limited capacity will need to expand. While the technology exists for both these types of vehicles, it's the logistics preventing them from being a reality. Between certification